This topic's going to be spread out over 2 videos. We're going to kind of go through the basics here, review some stuff from 7th grade math, and then go into more detail on the next video. So we're going to go into solving inequalities. Before we can actually solve them, we need to understand their terminology and how these work. So what is an inequality? Well, an inequality is like an equation, but instead of an equal sign, it has one of the following signs. So this is greater than, that's how we read it. Less than, greater than or equal to, and then less than or equal to. So this table is kind of like the table we did in section 1. As we move throughout the rest of this section and even the school year, when you hear another word that represents these symbols, add it to your table. So first, let's start with our greater than. Well, we know it's is greater than, so you have to be very careful that the word is greater than comes before it, because greater than could also mean to add. You also have is more than, exceeding, above, is larger than. Here we have is less than. This is so important that you understand. If the word is does not come before less than, and it's just the 2 words, less than, that means to subtract. But if it says is less than, that means it's the inequality. Is smaller than, is fewer than, is below. Now, these are just a few, and these are some that students have come up with over the years. You might know of more. So make sure that you add to it, or as we do word problems, you also add. Now we have is greater than or equal to. Also means is no fewer than, is at least. We know it's is greater than or equal to, or a minimum. So if you see a problem saying minimum, this is the symbol you would use. When we have less than or equal to, is not above, maximum, is at most, does not exceed, and of course is less than or equal to. So it's important that you have at least these written down, because having these, you can refer back to this table as you're working on word problems. Okay, so we have to be able to translate these. Okay, math is its own language, and we have to be able to understand how to write it. So we're going to start. It says is less than, so that's the symbol. I write it. What came before it was an X, so what comes before it is an X. What came after it's a 10, so we write a 10. Right there, I just translated it into an inequality. So we're going to go down here. Is greater than or equal to. So again, if you're not sure what direction it goes, you have your chart right there. It's going to go this way. 20 comes before it, so 20 comes before the symbol. Y comes after it, so Y goes after the symbol. Does that make sense how we do these? Now these are very straightforward. These are going to build a little more. So first, my eye looks for where my inequality terms are. And that's right there, is at most. Well, there's my symbol. Then I'm going to look, what came before it? Double a number. Don't make up a number. When it says double a number, or when it says a number, we don't know it. So I'm going to double X. That means times 2. Then 4 was after, so I put 4. There's my inequality. Okay, are you getting the hang of it? Okay, then I have is at least. Okay, so my symbol is going to now face the other way. What came before that was 3 plus a number. Again, 3 plus X. If you want to use A, go ahead. You want to use C, go ahead. You want to use N for a number, go ahead. Just they need to be lowercase. What came after it was 6, so I write a 6. Okay, let's move on to the next one. Is less than. So I have this symbol. Now look at this. There's less than again, but it's 5 less than a number is less than twice that number. That's why I said be very careful with the less thans. So the orange one actually means subtraction. What comes before it actually goes after. Remember, less than is a flip. That's from section 1. And then a number. Now, if whatever variable you chose here has to be the variable you use here where it says twice that number. So it has to be the same because it's whatever number was on the left, you're now twicing that one. Okay. Down here we have is at least. On the left, I have 3 times a number. So there's 3 times a number. But I also have plus 7. And then I had 9 by itself. So 9 goes on this side by itself. You are always welcome to do all these markings that I have here. I will never fault you. You might have to transfer it because you're computer based. But that's why I always say to have it printed out. It will help you. So let's go through what these solutions look like. Normally we've been solving when we get x equals 3, meaning that's the exact answer, nothing else. But here I have a range of answers, and these are called intervals. So on a number line, when you had exact answer, it's just 1 dot, that's it, that's my answer. But now I'd have a range of answers. So anything that's shaded there is a solution, meaning I could plug it in and it makes the statement true. We're always looking at what is a true statement. So this says I can only plug 3 in to keep it true. But here I can plug anything greater than 1. It cannot be 1. That's why there's an open circle there. It can be 2. It can be 4.567, 1.01, 1.000001. Anything that has a value greater than 1 will work. So it's super important here at this point. The symbol's on the left. When we graph it, it's an open circle. But it's an open circle on the number in the inequality. Nowhere else. Not next to it, not before it, not after it. Then, if it is our greater than, we shade to the right. If it's our less than, we shade to the left. This is what it would look like. Is everyone with me? If you have to, at any point, pause. You want to have these examples in your notes. Now let's come over here. If it has the or equal to, I'm going to do a closed circle on the number in the inequality. Now, if it's a greater than or equal to, I still shaded the right, but this is what it would look like this time. So let's just look and compare these two. The only difference is since there's a line, there's a closed circle. Then my is less than or equal to still shades to the left, but the circle is closed in now. Okay, let's go look at that. So I've got my 4 options up there in orange so you can reference them. If I'm given the graph and I have to write the inequality, this is kind of how I do it. So we're going to look at graph 1. I know I'm going to have an x, and my x should always go on the left. If you're using this trick of the direction of the shading, then the x has to be on the left. That's why I said in solving equations, I like to bring my variables to the left for this reason. Okay, so what I do next is, where's my circle? It's on the -2. It's an open circle, but it's on -2. So I write the number that is on. So that now narrows things down. I'm either going to have the greater than or the less than. It's shaded to the left. So if it's shaded to the left, I write less than. See how I kind of do this? Okay, let's go to graph 2. I'm going to put my x, we know that. then my circle is on -2. Everyone see? It just came up on graph 2, and it's shaded in. So that means I either have is greater than or equal to, or is less than or equal to. Well, what direction is it shaded? It's shaded to the left. So I'm going to have is less than or equal to. Okay, let's go to graph 3. I write my x, and my circle is on -2. So I write my -2. Since it's an open circle, again, it's one of these two. I don't know if you saw that, okay? Then it's shaded to the right this time. So I'm going to write greater than. On graph 4, okay, I'm going to write my x. Look at this. It's a closed circle on -2. So I put a -2. Since it's closed, it means I have one of these two things. Well, it's shaded to the, it's shaded to the right. So let's go see this in a word problem. How would I do this? The Rams at Inglewood High School are seeking to raise at least $750, change the number, in a fundraiser to pay for their end of the year field trip to Islands of Adventure. Write an inequality to represent this situation. Well, let's go back and read things. They're trying to raise at least. There's that key word, okay? At least was where? What box was at least in? Right here. See it? Okay. So I know what symbol I'm going to use. Well, what am I trying to do? I'm trying to find X, the minimum amount needed, right? So I'm going to put my X. That's what I'm looking for. They want to raise at least 750, meaning can they raise more than 750? Yeah. And 750 is that magic number that goes there. Then when I graph this for my class and Mrs. Nell's class, this is how we don't mind you graphing this way. Put the number that it is. You don't have to put a million other ones. Just put it in the middle. You need to have the correct circle on the number, and then you have to shade in the correct direction, okay? So you don't have to write a million different numbers there. There are some teachers that make you put 4 below, 4 above. For us, you can do this. You can put 1 below and 1 above. I prefer that so that I know the direction you're going. So some of this was review, and it's just basics of inequalities and graphing them. We didn't get into solving them. This is just how we graph them and translate them. So what did you remember? If you remembered it, click like. If you don't remember something or you don't understand it, write that in your summary and comment below.